The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Welcome to our AMS webinar in August 2022 as part of our continuing AMS webinar series. Today, the title of our webinar is Two-Sided or Flip Machining in MecSoft CAM. We're going to be talking primarily about Rhino CAM, but it'll be applicable to all the other CAM products, Visual CAM as well as Visual CAM for SolidWorks. My name is Joe Anand. I'm the product manager here at the MecSoft for all the CAM products. I'll be joined together by Don LaCourse, our senior application engineer, who's actually going to be doing the demonstration show and tell, and also the demonstration of these features. Before we get started, some notes for you. You can use your chat window for questions. That's the blue arrow if you see on the right on the graphic. The chat window you can put your questions in there as the webinar is progressing, and then I will be in the background listening for these questions, and we'll get answer them as soon as possible. And then if we can't get to any of these questions, we'll definitely send you email or any follow-up responses to these questions. Typically, the last 10 minutes we reserve for questions and answers if there are a lot of questions, but typically lately we have not been doing this because we tend to run over time. But we like to keep this as interactive as possible, so use the chat window for your questions. We prefer that rather than wait at the last 10 minutes. And as usual, the recording of this webinar will be made available maybe in a couple of days. Give us a chance to clean it up, and then we'll post it. We'll send an email to all the registrants of the webinar so you can watch it at your leisure. Okay, so the agenda for today is, as I mentioned, two-sided or flip machining. And then the topics we're going to be talking about is, we're first going to start with what is two-sided flip machining, defining that. And then, do I need it? How can I tell? Some of you might not even be familiar or aware that you might need it. And we can teach you how to determine that. And then we also talk a little bit about the differences between the standard and the professional configurations. What would you need in terms of how do you program flip machining if you had the standard as opposed to if you had the professional configuration? Because in the professional, it's a lot easier to do this. And then basically the techniques. The three techniques we're going to be talking about are bridge and flip, which will be applied for basic 2.5 axis machining. This will be followed by the box and flip. These are kind of fancy names that Don's come up with, so you will be able to remember it. And the box and flip is tailored for basic 3-axis machining. And then finally, for advanced 3-axis machining, he's got a technique called flip and jig, and he's going to go over all of that. So without any further delay, Don, please go ahead.
Hello, everyone. Thanks for joining us today. As Joe mentioned, my name is Don LaCourse. I'll be showing you some techniques for two-sided machining in MecSoft CAM. This first slide we have up is just a simple understanding of what is two-sided machining. Basically, if you have a feature on the opposite side that you have to machine, then obviously it's two-sided machining. And you may want to consider, how you're going to machine that. If you're definitely going to, machine it on the CNC, then obviously you have to flip it over and do a second setup. So how can I tell, or how can you tell if you need two-sided machining? Well, during your initial analyze of the part itself before you start programming it, obviously you're going to sit down, you're going to look at the part, you're going to determine how it's going to be machined, how it's going to be oriented on the machine, and those kinds of things. So basically, if you see an undercut, as shown on the screen in red, then you can't machine all of it in one setup. Obviously, the tool is not going to bend down there and cut that out. So if you see an undercut, then you need to make a decision whether you are going to flip it or whether you're you're going to leave it the way it is and do it, manually from the other side, or how do you want to do that? This particular example is a sculptor, so they just decide they're going to do it on one side, and then they'll take the part and hand sculpt out the undercuts. So basically, anytime you see an undercut or feature on an opposite side, you're going to need flip machining if you're going to machine it. Now, what's the difference between performing two-sided machining in standard versus professional? The major difference is, if you look on the right, for the standard configuration, you need two files. In the standard configuration, you have one setup which is oriented, with your world coordinate system. So the part in that orientation can only be machined from the top side in the standard configuration in that file. So basically, you have to save out the file to a second file, which would be the opposite side, and then in that opposite side file, you'd have to physically flip the part over, redo the stock parameters, alignment, etc., and machine the second side. If you have the Pro, life will be a lot easier for you for doing this, primarily because you don't need a separate file. You can just add a multiple setup. As you can see in the machining job here, we have setup 1 for the top side, setup 2 for the bottom side, and basically you're just orienting setup 2, orienting the coordinate system such that you are facing the bottom side. And it does make things a whole lot easier, especially as your parts get complicated. We're going to show you some, the basic workflow with just a very basic part, so you can understand the workflow. But we're also going to show you an actual production part, and you'll see how much more complicated it can get. Here, I've come up with 3 basic techniques for flip machining. And the first technique is, if you're just cutting basic 2.5 axis parts, and if your part has a feature on the opposite side, obviously you're going to want to turn that over. So on the left, the key to doing this, especially in sheet stock, basic 2.5 axis won't always be sheet stock, but we're just using a sheet stock as an example. So basically, you're adding bridges to the tool path so that the part doesn't become completely separated from the stock when you're cutting the first side. Then after you're done cutting the first side, you'll take the stock off the table, flip the stock over. I have it flipped over along the x-axis, and add your work 0. You'll notice here the work 0 is in the same location, bottom left corner. That's important. And on the second side, the flip side, in this example, we're doing another profiling operation which separates the part from the stock. Just one second. Now, again, here is a production example of the bridge and flip method using the same part that we showed before. So basically, the important thing to remember in each of these types of flip machining is that the part and the stock are aligned in the center, in the X and Y, and in the Z. Obviously, in a sheet machining like this, your thickness of the stock is most likely going to be the same thickness of your part, so it will automatically be aligned in the Z-axis. But you really need to have it aligned in the X and the Y also. These techniques will only work properly if your part and your stock are aligned, because when you flip that over, you got to have the same condition on the opposite side versus the top side. So here we see the top side of the part. You can't really see the tabs very well, but the tabs are in there. This is maintained as one stock sheet. You can pick that up after setup one. These will all stay in the stock. You flip it over, and then you program side two and run it on the machine, and side two will remove the part from the stock. So that's just basic basic two-axis sheet machining. We'll call it bridge and flip, only because you're bridging it. You know, if your table has a vacuum table, you're still going to need the bridges, only because you need to take the part off the table and flip it over. So, and then obviously, if you have a vacuum table on when you're running the opposite side, it'll help hold the part to the table while you're machining. Okay, let's talk about a basic three-axis two-sided machining. I'm calling this box and flip. The box refers to a box stock. It's just a standard box stock that you provide the X, Y, and Z dimensions of the stock. So I'm going to start over here on the left, on the top. This is the part that we're illustrating. We got the top view, the front view, and the bottom view. You'll see that there's features on both the top side and the bottom side, and there's obviously features around the perimeter. Obviously, you can't machine this from one side because you have undercuts over here that you can't get at. So in this technique, instead of using tabs or bridges, we're modeling the tabs into the part, and that's what you see in the middle row here in green. So basically, we just extruded a solid cylinder through the X and through the Y. The length of these cylinders, it's not that important, only that it extends past the part significantly enough so that you can, you know, get a tool in there and cut this out. So we got two rods, X and Y. We've got a curve, which is a circle, and that circle lies on the XY plane. So that circle is going to contain the tool paths within that area. So the tabs or the rods that we model have to extend past that circle. If you don't, then it's just not going to be held together. So if you move over to the next third column, you see we simulated the top side, and you'll notice that the areas where the rods were, the machining skipped that area. Obviously, any geometry that's visible when you generate an operation in three-axis automatically will be checked against for gouge-free toolpath, means that it will not cut into that area, and it just has to be displayed whenever you generate the toolpath. That's all it has to do. As long as it turned on and you can see it on the screen, when you generate it, it won't cut through those. So you can see on the top side, we machined everything down past the center of the part, basically past the quadrant of this arc on the outside, so that you machine past that point. And you can see when you flip it over and then you do the other side as well. Now, when again, just a square box, the part and the stock is centered, X, Y, and Z, so that when you do the one side and then you flip it over and you set the setup to the same position, it will line up automatically for you. You won't have to, the complexity of the part does not matter. The only thing you need to make sure is that the part and the stock are aligned in the center. And I know you're gonna ask me, well, what if it's not? And we'll talk about that, how to do that in just a moment. So that's the basic box and flip in three axis. And I'm going to show you a production application for that. So you see we have the tabs modeled, they're in green, okay? We got 3 cylinder rods here on one end. On the other end, we don't have a lot of room for a cylinder rod, so we modeled just a square block that comes in underneath the part on the end. And like I said, it doesn't have to be a cylinder. It can be any type of surface that's going to break up the tool path on each end so that it, you know, remains connected to the stock material. So on the very top left, we see the part. This is a scanned part that for a woodworking technique. So we have 3 copies of the part here on the left, and you'll notice that not only do we have the bridges modeled, but we also have curves drawn on the XY plane. The first rectangular curve is to contain the roughing operation. The profile curves in the center of the part are for the finishing operations, and then the purple surfaces you see here are positioned so that the tool, when you do the 3-axis operation, it has a surface to land on. In other words, if there's no surface under the tool in 3-axis, the tool will automatically retract to the clearance plane. So instead of, you know, tool retracting over and over and over and over, just put a surface under there for the tool to land on, and that surface, it just needs to be at the Z location, you know, to make sure it encompasses the entire part from one side, and the tool will land on that. As you can see in the simulation over here on the right, the plane, rectangular plane, is where the tool stopped on, and it machined all of the part with the tabs, as you can see on each of the ends. And then this is then flipped over. The parts, there may be 3 parts, but all 3 parts are centered in the stock, so that when you flip the stock over, everything's aligned automatically. So that's a production example of the box and flip method. Again, if you guys think any questions, just put them in the questions panel, and we'll answer them for you. Here's another, the bottom side to this particular part. Here you see the rectangular tabs. They extend in underneath the part just enough to hold them to the stock itself, and you can see the bottom side simulated here with the tabs. And you also see that the part is completely separated everywhere except for the tabbed areas. So you basically do side 2, take it off, and you'll have to manually cut these tabs off and, you know, clean it up on the ends. Now, what if you have a little bit more complicated 3-axis part? And hold on just one second, I want to double check something. Okay, so our advanced 3-axis method we're calling a flip and jig. No, it's not a thingamajig, it's a flip and jig. So basically what you're doing is you're machining the first side, then you're flipping it over, and instead of using tabs to hold it together, you're actually going to use a fixture or a jig to hold the part. So again, we're going to start over here on the left. We got the same part as we did in the prior example. We have a part with a feature on both the top and the bottom that needs to be machined, and also the perimeter needs to be machined. So we created, in the middle column, we created the stock box, okay? And we oriented the part within the stock. The orientation of the part in the stock is not as important in this type of flip machining, only because you're going to be using a jig or a fixture to automatically align the part when you flip it. So you just need to, you know, define your stock well enough, obviously, to machine the top side. So in the bottom here, we see we machined the top side. This is the cut material simulation. We left material on the bottom just to keep it together into the block of the stock. So when you flip it over, and in the third column, you see you have to prepare the jig or the fixture that's going to receive the part once you flip it over. So this will have to be programmed and machined along with the part itself. So the neat thing about we have a production example coming up. The neat thing about that in the pro configuration, you can program the top of the part, the bottom of the top, bottom of the part. You can program the jig and the fixture all in one part file and keep it all together so it's less confusing. So in the
Hey, Don,
yes,
I
Joe.
just want to interject here and say one of the things that might not be apparent, very clear is the flip that you're doing. You have to flip it about an axis. So basically, the flip means you're rotating about an axis. In this particular case, you can rotate about the x-axis. And then you got to make sure that on the machine tool, you're flipping the part about the same axis.
Yeah.
That is, you're flipping or rotating the part about exactly the same axis. I mean, obviously, you can't rotate the part by a different axis, and then you're going to get into problems. So that's important to observe. So.
Okay. So again, in the third column, we have the in-process stock. We flipped it over. We placed it in the fixture, so it's holding it. Again, we've got a production example coming up. You may be asking, well, how's the part going to stay in the fixture, et cetera, et cetera. We're going to talk about that. So let's go and look at a production example of this flip and jig. So if we start on the far left, we have a part that obviously needs to be machined on two sides. So if you look at the cross section of the part with the dimensions over here, we have a curvature on the inside, a curvature on the outside. We've got a flange on the bottom. So obviously you can't machine this all from one side. So we're machining it from the top side. If you look in the second column, many cases also the purple or magenta surfaces. In this particular example, we have critical edges that we don't want to lose the definition of. And those are the sharp corners on the bottom of the part, both on the outside and on the inside. So what we did is you add a surface. The flat surface here is to, again, a place for the tool to land on. So you'll see in the center view here with the arrow coming down, the tool will have to stop on that circular surface right there and not go all the way through. And then the red and the blue dots signify where the parting plane is. In other words, you got to go at least past the blue dot on the inside. And then we have a surface added at one of the red dots so that it guides the tool past this edge. That's what those surfaces are all about. So on the third column, we're machining the bottom of this part first. So we're going to be fixing it when we tip it over. So all we need is just a circular round stock, and we're programming the bottom side. So we have the roughing operations in the top view, and then we have a finishing operation in this view here. So if you move over to the final column on the right, on the bottom, you see the cut material simulation of the part. This is what it's going to look like after the bottom side is machined and you take it off the bed. So you're still going to have a circular stock. You're going to have your flange machined, and then you're going to have half of the inner area machined down past the quadrant plane. And this is the surface that we modeled so that the tool wouldn't go past. So now, depending on the operations you use, you can contain your tool path in the Z-axis. In this particular case, it was more convenient to just put that surface in there. So let's look at it when you flip it over. So in this example, we have a nice circular flange on the bottom of this part. And if you look at it, you can see the flange right here. And that's a perfect feature to fixture the part on. So we have, if you start on the left side at the top, we have the jig or fixture, and you'll see that it has an area for the part flange to sit on, and it's got all these holes around it, and it's got holes in the corners. Optionally, if you want to fasten this down to your table, you can use the holes on the corners, or you can hold it however you want to hold it. If you're using a vacuum table, these holes will help hold the part down, and I'll show you this in more detail in the actual part file. But down here on the left side bottom view, you see that we have the fixture with the part on top of the fixture. Now this is not the cut material simulation. This is the actual part model in the CAD file. So when we machine the top side, we have another flat surface that they're shown in green, which is positioned below the quadrant area on the inside to catch the tool. And then we also have this surface that we see in green at the bottom edge. That surface is actually modeled in the fixture as you see it around here. And basically that's just going to guide the tool past that edge to maintain that feature in the actual part after it's machined. So in the second or center column, you'll see in the top, you'll see the in-process stock. It's already been cut on the bottom side. It's been flipped over, and it's been set on the jig or fixture. So the alignment of the inner bottom flange aligns with this flange here. So you're basically automatically being aligned along the center of the part itself. And here in the bottom view, we're just showing the roughing operation. And on the view on the far right at the top, you see the finishing operation. So this is the actual cut material simulation. You'll see that it machined it, looks really nice on the inside. It's got an area here that helps guide the tool past this edge here. And if you look at the cross section here, you'll see the edges here on this point and the edges on the inside. Those are all maintained during the machining process. And then also this particular fixture has a chamber on the bottom, which allows the vacuum to be pulled through the fixture and hold the part down during machining. And if you got any questions on this, go ahead and go ahead.
Yeah, one of the things that I want to point out is, if you're a job shop and you're getting this part, you have to actually think through this process of, how are you going to you have to actually design the fixture yourself as a machinist or a manufacturing engineer. So you can get pretty creative. You can use your creativity actually to figure out what is the best way to fixture it. So we're just giving you examples, but really there's a lot more involved in trying to figure out what is the best way to fixture or create the fixture. And then you actually have to design it in the CAD system and possibly machine it in the CAM system first before you can actually machine the part.
Yeah.
So it's quite complicated. So even though we're glossing over the details a little bit here.
Yeah. And, obviously, I'm just going to reiterate what you said, Joe.
Yeah.
So when you come back and watch the webinar and the recording, you can look at these in more detail, obviously, and as far as take more time than we're taking to go over it. So this is an example of what we're calling a flip and jig. You're machining one side, you're flipping it, you're putting it in a fixture, and you're machining the opposite side. Now let's take a look at these three examples in the actual CAD file. Okay, so right here we've got our basic 2-axis part. You'll see that it's got features here on the top side, and then it's got features on the bottom side. So you got to machine it from both sides. So how would you have to go about this in the standard configuration? We mentioned previously that you can only have one setup in the standard configuration. So the part right now, as it appears on the screen, is oriented for machining the top side. So let's go ahead and define the stock. We're just going to pick a box stock, and here it's going to be easier for you to do this if you have stock dimensions that are whole numbers, just to keep things simple for you. So we're just going to do 10 inches here, and that's 5.5. We'll do 8 inches there, and obviously 3/4 of an inch stock. We'll leave that. We're just going to pick OK. So there's our stock. Again, we keep iterating that it's important to have the stock and the part aligned together in the center. So we're going to go ahead and pick a line. We're going to go align stock, and we're going to do for the Z alignment. The part and the stock are 3/4 of an inch anyway, so it's going to automatically align. But just get into the habit, and we'll just pick center for Z and center for X and Y. So now you see that the part and the stock are aligned perfectly in the center. Now, the next thing we want to do is we want to make sure that we're using a origin or work zero that's in the bottom left corner. And it can be any point, top or bottom, as long as it's the same point when you rotate it over along the x-axis. So what we're going to do is we're going to pick a line, and we're going to do set world CS. This actually will move the part in the stock to the origin. It just makes it a little bit easier to understand. So we're going to set it to the stock box. Again, in this dialog, we're actually defining the world origin. So the part is going to end up being moved in relation to the point that we're defining here. So we're setting it to the top stock box. We're going to set it to the lowest Z, and then we're going to set it to the southwest corner. So the origin, the world origin of the part file will be at this position. We'll pick OK, and you'll see that it moved over to the world origin in the CAD file. So at this point, let's go ahead and just throw in some toolpaths for side one. And then also, to make it easier for you to understand, we're going to go ahead and put a work zero in here in the same location. Okay. So here is the world origin, and here is the work zero. So we have the work zero for setup one, oriented in the default orientation of the world coordinate system in the CAD system. So if you're using the standard configuration, you're going to do all of this first, and you're going to program the part all from the top side. And the pocketing, we have a pocketing and a profiling operation in here. We're not going to regenerate them, but I'm just going to show you. We got our bridges and tabs set. Everything else is set to cut out this profile and to cut out the pockets for the top side. Now, if you have the standard configuration, again, I keep reiterating this is as far as you can go with this part in this file. So in order to machine the bottom, we're going to actually save this part out, and we'll just call it top side. Okay. So now we want to flip the part over and machine the other side. So we do have a orient part option, which allows you to flip it. But in this case, I'm going to use Rhino's tools to do it, only because I have a lot more control. I want to make sure it's rotated about the x-axis. So I'm just going to do a Control-All from the keyboard. It's going to select everything that's visible. And we also see that the gumball, there's an option down here at the bottom called gumball. And this allows you to transform anything that you have selected. So what we want to do here is we want to rotate about the x-axis. So we're just going to grab the red arc, just pick it, and it opens a field, and we're just going to do a 180, and it flips it over. Okay. And also we're going to go and make sure that the stock is correct. 10.8, it should be the same as the other file. We'll make sure the alignment is correct. Center and center. Okay. And also the bottom left corner, the same position that you machined the top side, is aligned at the world origin, and our work 0 is at that location. So what we're going to do, we don't need these operations. We're going to bring this bottom set of operations over. So these are for machining the bottom side, the roughing, profiling, etc., finishing, more profiling. So this is a basic flipping the part with tabs being machined, or bridges. So if you wanted to do this in the professional configuration, let's go ahead and load the top side again. Once you're done here, obviously you save that out as the bottom side. We're just going to go ahead and load the top again. Sorry, no, we don't want to save it. And we're going to go bridge and flip. Okay. Let's go ahead and do the one we machined, though. The bridge and flip. Okay. Okay, let's go through that again real quick then. We're pretty good on time. Let's go 8, 10, 7, 5. Okay. We're going to align it. Okay. We're going to move it to the origin. Okay. Okay. So now we're all set. And let's load our knowledge base again real quick. Okay, so now we're going to bring up our operations. Let's go ahead and create our work 0 again. We're going to do lowest D, bottom left. Well, hold on a second. Let me double check that. Stock box, bottom left. Okay. Okay, so we got our work 0 for the top. We're going to drag these operations here for the top. So this is the point that we were at in the standard configuration where you'd have to stop and then create another file and orient the part and do the bottom. And during that whole orientation, everything, you got to make sure that everything's aligned, everything is, set up the same way. And you can obviously understand if the part gets complicated, that can be complicated. And then something could go wrong. And then when you machine the bottom side, it won't be aligned, and you'll be scratching your head on what to do to figure that out. So basically, in the professional configuration, we're just going to add another setup, and we're going to rotate this setup about the x-axis like we rotated the part. So we're going to use a spin angle of 90 degrees, and then pick the x-axis. So you'll see that the axis rotated 90 degrees. We're going to do it again. So it's pointing downward, and we'll pick generate. So now we have the stock and the part aligned. We don't have to move anything. All we're doing is creating another setup pointing in the opposite direction at the same location as setup one. Okay, so what we're going to do here is we're just going to, roll this
Can
over.
we look at the toolpaths? And
for the top side?
Yeah.
Okay.
Or the bottom, whatever you've generated, right? So.
Okay. Okay. I don't have these selected, so I'll go ahead and do that. Let's double check that.
Yeah, I think you selected the wrong thing in one of those. Yeah, you can remove that.
Do a shift key, select.
I think the important thing is that the bridge and tabs, I think.
Yeah, so something is not picking that right. Let's do it differently then. Remove that. We'll just do it that way. Looks like we lost them all, so let's try that again. Okay, and then the profiling, we're just going to do
the outer edge, yeah. Yeah, the important thing here is the tabs, bridges and tabs. So that's what. Oh.
Okay, let's make sure the tabs are in there. Okay. Okay, it's putting the tabs in there. It's not putting them where I want. So we're going, you can use the regions tab to create a machining region. We're getting into a lot of other areas, but basically, this is the top side where you got these features: machine, you got tabs. All those are not in a position we want. We can change that later. So now we have set up 2, and we're going to just roll this over. Okay, the same orientation, and then we're going to add another work 0, and we're going to use it to the same, put it in the same location. Okay, so now we're on the bottom side. You flip the part over, and we can go ahead and use these operations on the bottom side. So I can grab it. Okay. So basically, then you would just go through and program it like you normally would on this bottom side. So you can imagine, as the part gets more complicated, being able to do it all together in one file, as I will show you in a moment when we get to more complicated examples. If you can afford the Pro configuration, I highly recommend that you get it if you're going to be doing two-sided machining, only because it's going to save you a lot of time, a lot of head scratching, and probably a lot of stock material, because you may machine it incorrectly the first time. So that's the problem. That is the main difference. Obviously, between standard and pro, there's other differences. You have a lot more tool paths. Obviously, you have all the 3-axis, advanced 3-axis tool path. You have additional roughing and re-roughing operations in 2-axis and multiple setups, just all kinds of things that you have additional for the Pro versus the standard configuration. Okay, let's look at the bridge and flip. Let's look at the box. What do we have? A stock and flip. Okay. While this is displayed, let me just go over another thing here. I mentioned in the presentation, obviously you were asking yourself, well, what if I can't center the part in the stock? What if I need to use part of the stock maybe to fixture it, or you know, anything can happen in the way what you need to do in order to machine a particular part. So you may not be able to align the part and the stock together. So what do? Basically, what I recommend that you do is model your stock in the CAD system. So what we're going to do is for now, we're just going to turn the stock off so we don't see it on the screen. So let's go to a multi viewport. I'm just going to model a box just to represent a stock, irregular stock. So we're just going to do a solid box. Okay. So what we have then is we have your stock modeled and the part. So just physically move the stock and the part together, so that they're aligned the way you want them to be aligned. So we're just going to move this up. We're just eyeballing it here where it's the stock and the part is where we want it to be aligned. In this particular case, it's inside the stock and the Z-axis, and it's somewhere off center in the X and the Y. So we can see that a bit better. Yeah. So now that you have your stock modeled, and this applies also if you have an irregular stock, or if you're going to define a stock from selection that you can do in the Pro configuration. A lot of times shops will actually build up, a stock, using wood or whatever materials. This typically doesn't apply to steel, but if you're machining wood, you can glue up your stock model to the shape that you want. And then you can model that shape in the CAD system. So at this point, we're just going to follow the same procedures. We're going to go ahead and create a work 0. We're doing the exact same thing. Bottom left. Okay. Let's double check that again. Okay. So here's another thing to point out. Once you model the stock, let's actually define it. So we're going to define the stock. Here we're just going to pick copy model bounding box. We don't need to put any dimensions because we've already modeled it. Just hit copy model bounding box. It'll snap to your stock box. Pick OK. And then a very important thing to remember, after you have defined your stock, you need to hide your box. Oops, sorry about that. I don't know what this is up there. I guess I didn't grab that whenever I rotated it. See, there's a good point. There's a good point right there. I had to physically rotate that over, and for some reason it didn't grab a couple of surfaces. So now you're scratching your head. I've already flipped it. I already aligned it, but I lost a surface. So now you got to go back and figure it out or do it over or whatever. So with the Pro, it takes care of that. You don't need to worry about that. But I'm just going to hide this. If you don't hide your box and you try to perform a 3-axis operation, it's going to come back and say there's nothing to cut because it can't cut any past your stock box because it's visible. So now, you can go ahead and there's your stock box and go ahead and go through the process of defining your work 0 for one side, and then you're going to flip it over to find the work 0, etc. So this just keeps it all aligned for you together, the part and the stock, and you can make sure it stays aligned together. Okay, so let's go to another part file. And let's look at production, bridge and flip. Okay, so here is the bridge not the bridge and flip. I guess you would call it the, what did we call it? It's the one with the extrusions. We're going to add extrusions on each end. And in this example, I showed you the picture of the cut material simulation. Basically, so you're doing the same. If you have the extended configuration, you can only machine one side. Then you'd have to physically flip it over and machine the other side. So you can see here in an actual real world example where it makes it a lot easier with in the pro configuration to actually machine both sides. And you know, we could go ahead and simulate it, but I got a more complex part I want to bring up and make sure we review that as well. So in this example, you're modeling your tabs in green. Let's go in the top view. We've got curves defined. That's a rectangular curve to contain the roughing. We got offset curves here that are going to be used to contain the finishing operation. And then obviously we have our rectangular flat surfaces that we're going to use to catch the tool during the 3-axis operations. Okay, let's go over again. Is there any questions, Joe?
Not at this point, no.
Okay, we got about 10 minutes. Let's go over the most complicated one. So flip and fix. Let's close the bottom area. So in this one, you can see we got a fairly large machining job. And I'll just go through this, which is the one where we machined it and flipped it over and then set it on this fixture. And then the fixture has a chamber in the bottom. You got holes around it to help hold it down. And basically, we're in this. This will be very, very complicated in the standard configuration. It can be done. I mean, as long as you keep, you know, everything coordinated, everything set up correctly, you won't have a problem doing it in the standard. But it's going to be a lot easier to do it in the Pro. So basically, like I mentioned in the presentation, we machined the bottom half first. So let's go ahead and turn off the fixture. Okay, we'll just roll this over. Okay. So here we're machining the bottom side, facing, machining the lip. Here's our roughing, more roughing, and then finishing. That's side one. Now we're going to create another setup that's going to orient. You'll see that the Z-axis is pointing up. In the setup 2, the Z-axis is pointing down. So now we're going to just rotate this over again. And at this setup, we're going to do the top side. So we have our work 0. We have our roughing. Again, let's turn the fixture on because it's going to be set on top of this fixture. And I mentioned let's turn this toolpath off for a moment. The guide reference surfaces or guide surfaces, I guess you could call them, to help guide the toolpath. We have, let's see, let's turn this up again real quick, and let's turn. Okay, top side. Okay, so here's just a flat surface that's going to a place for the tool to land on. It's oriented past the quadrant, you know, on down a little bit in the part. And let's go ahead and look at the fixture again. This surface right here, which is part of the fixture, is actually going to guide the tool past this edge. So you're going to maintain a sharp edge here as required by the part. Okay, so let's turn the fixture on. We'll turn that off. Okay. And we're at this point, we're machining the top. So again, we got the roughing and we got a horizontal finishing. This is a pre-finishing operation and then the final finishing operation. And if you look at this, let's go to a front view. Let's see that, and let's change this so we can somewhat see through it here. Okay. So what you're seeing here is we have this surface. This is part of the fixture. The tool path, the tool is guided past the sharp edge right down onto the fixture, which is really no big deal. It's part of the fixture anyway. So every part, you could just reuse this fixture over and over and just set the part down on there and machine the top side. So now what we was mentioning about the fixture, we actually have, let's see what this is. This is the, okay, we got the fixture here. Let's turn the part off. Let's turn the fixture plate. Okay. Okay. So we've got, let's look at the tool paths here. The fixture itself is a flip part. So it's a two-sided part just to make the fixture. So we made the program, the bottom side, the locator pins, the pocket on the inside. All that is machined out for the bottom side. And then also we got to flip it over and do the top side of the fixture itself. Okay. So basically you're machining the fixture along with the part, flipping the fixture for both sides, flipping the part for both sides. Everything can be maintained in one machining job in one file. And this, this is a relatively complex, but they can get more complex than this depending on the part geometry. So the main thing to remember on each of these types, if at all possible, make sure your part and your stock are aligned in the center in relation to each other, regardless of where you're setting it, where the work zero, or where it's going to be on the machine. That none of that matters. Just the part and the stock is centered. Once you define that, then you can locate your work zero somewhere on the stock. That's where it's going to be sitting on the machine. That's where the tool paths are going to be measured from. And then when you flip it over, you use the same location and it maintains the location of the part within the stock. So you just boil that down to one thing that you got to remember is to center the stock and the part, and you should be okay. And if you can't do that, model your stock and position it with the part. But don't forget, after you define your stock based on your model, make sure you turn the model off, turn the geometry off, because if it's visible, 3-axis toolpaths, they won't go past your stock and it'll just tell you there's nothing to cut.
Yeah, one other technique that you can use for positioning the part after you flip it is these registration pins, which Don talked about briefly here. So there's holes on the 4 sides. You can actually set up registration pins for your part on the stock model. And then when you flip it, you stick it back into those registration pins, and that way the dimensions will be correct in terms of machining from either side. So that's another technique that people use. So
yeah, because this particular part, it has designed to have it aligned here with this area in the fixture, but that's just for this part. So you may not be able to do something like this. So then, as we mentioned in the beginning, when you're looking at this part and you're figuring out in your mind how you're going to program it, You also have to figure out how you're going to fixture it, and you may need to add registration pins if you can't fixture it any other way with clamps or whatever. A lot of times shops will use the registration pins, and that obviously it helps align it when you flip it over. Let's see if we can, actually we're right at an hour. Do we have any questions, Joe? It looks like, let me take a look here. Okay, looks like we've covered everything. Okay, here's a question here. Can you post both setups in the top in a TAP file, or any NC file? So
Yeah, I answered that question
yeah,
actually. So yeah, you can do that, but your post has to be set up for each setup. I mean, I say setup, the post has to be configured. Let me rephrase that. So that when the post processor encounters a setup operation, the correct code is being output. So that code needs to be configured in the setup of the post. So
yeah.
it can be done.
So whenever what Joe was saying here, if you're posting an entire machining job, you're going to be outputting setup orientation plane codes. So as Joe mentioned, they need to be set up in the post.
If you want to bring up the toolpath editor, I'm sorry, the post processor editor, I can quickly talk about that. So
Okay.
just edit. So go to the setup tab. So yeah, here in the setup tab, right now there's some code set up for setup 0 and setup 1. And if you want to put a pause operation, you need to stick that in here. So when the post processor is running, it will encounter, when it encounters the setup, the code that's in this edit box will be output. So that's how you would do it.
And we can help you set that up if you're
Right.
not familiar with the post process generator.
If it's something simple, we can help you set up. Since you're all on maintenance, we can help you with that. But if it's something complicated, we can talk about that offline. So.
Okay, it looks like we're about right at 1 hour. If you guys got any more questions, feel free to just email us at support@mecsoft.com. And being AMS subscribers, you get priority support. So if you're not on AMS, you go to the bottom of the support desk line. So every day, all of the AMS subscribers get addressed first, and then after that is done, then the non-AMS subscribers get addressed. So.
All right. Thank you, everybody.
Okay.
And then see you next month.
Okay. Y'all take care and have a good evening.